I would like to start by welcoming you all to the 15th webinar of the Graduate Program in Physics of the Federal University of Pará in Amazônia, Brazil. I ask you to kindly leave your audio and video sources turned off, except for the moment you're going to speak. Questions will be allowed after the webinar, unless otherwise requested by the speaker. The questions can be asked using the chat, okay? Today we are very honored for the opportunity to hear from Professor William Dean Brewer, who has visited Amazonia on some occasions, but never gave a talk in our graduate program, and therefore this moment is really special for us. Bill Brewer is a professor at the Freie University of Berlin in Germany. He was born in Idaho in the US, received his Bachelor of Arts in Chemistry and Mathematics from the University of Oregon, Eugene, and his PhD degree in Physical Chemistry at the University of California, Berkeley, also in the US. On 2 occasions, he has been Dean of the Department of Physics at the Free University of Berlin, and he has also been the chair of the PhD committee of that department. The research fields of Professor Brewer include magnetism in metals, magnetic thin films, photoelectron spectroscopy, valence instabilities, and nuclear models. He visited Brazil a number of times and had fruitful scientific collaborations with Brazilian scientists, including Professor Sônia Frota Pessoa, that is with us today from the University of São Paulo, as well as Alberto Passos Guimarães Filho and Elisa Maria Baggio Saitovic from CBPF in Rio de Janeiro. In the past 10 years, he has been interested in the history of science, translating a number of papers and books relevant to physics history, and has worked with the Einstein Papers Project, transcribing and translating Albert Einstein's letters and papers from German and French to English. Recently, Professor Brewer co-authored with Alfredo Tiomno Tomaskin, that is also with us today, an outstanding book about Professor Jayme Tiomno and Elisa Frota Pessoa. And this is the subject of his talk today. So, Professor Brewer, thank you again very much for having accepted our invitation. We are very happy with this moment. The audience is yours.
Thank you. I'm very happy for the invitation also. Thank you for the introduction. And I wish I could be in Belém. I have very pleasant memories of Belém, but unfortunately circumstances don't permit that these days. So we'll see how this works. I suppose you can all see the title page here, and the book that Luis mentioned is given down here at the bottom. I'll refer to it a few times during the talk. It won't be possible, of course, to cover even a small fraction of what's in the book, and so I decided to try to make the emphasis in this talk on Tiomno's scientific work. Alfredo Tomaskin is going to give a talk in another lecture series next week, and I expect he'll say more about things like how the book was written and where we got our information and so on, since that's his field as a historian of science. So I have prepared a manuscript, which you can see here, and it's available as a PDF, and after the talk, you'll be able to download it if you're interested. I won't, however, during the talk, even be able to cover everything that's in the manuscript, because time just doesn't permit that. So we'll plunge right in and see how far we get. I skipped over the abstract because that's been on the internet for some time, and anyone can see it if they want. The talk is divided into 5 parts. The introduction is about the early history of Jayme Tiomno, about his family and his education. The second part takes a step back from Tiomno himself and looks at the major themes or major threads in fundamental physics in the 20th century. just to give a context to what Tiomno was doing. And in fact, he worked in all three of these major fields. Whoops, excuse me. And those fields are particle physics, gravitation, field theory, general relativity, cosmology, and fundamentals of quantum mechanics, perhaps also quantum gravity. Now, these three fields actually came independently of each other, and they all started about the end of the 19th, beginning of the 20th century. And I'll go into a little bit of detail, but I won't be able to cover that in really thoroughly. The main section is section 3 on Tiomno's scientific work. About his early work, some will be mentioned in the introduction. His thesis, which was actually very important and didn't receive the attention it deserved at the time. His work in Sao Paulo up until 1952, when he joined the CBPF in Rio. And we have to remember that Tiomno was really one of the founders of the CBPF, even though he wasn't there at the moment that it was founded. He was working in Princeton at the time, but still he and José Leite Lopes and Cesar Lattes and Elisa Foto Pessoa were really the four people who had the vision of starting the CBPF. There were many other people involved in actually founding it and getting money and support for it and so on, but those were the four people who had the idea a while before it was founded, and whose idea then finally came to fruition. And then at the end, we'll talk about Tiomno's return to the CBPF after he had been banned from working there for 10 years, more than 10 years in the 1970s. The last two sections, I'm not sure we'll have time to get through to them, reflect two very typical characteristics of Tiomno. The first one was that he was very interested and very eager to set up infrastructure in Brazil, educational institutions, research institutions, so that it would be possible for people to do fundamental physics and to be educated in fundamental physics. That was really a major goal in his whole life. And in this fourth section, I would just mention some of the institutions he was involved in founding. The ICTP in Trieste is, of course, not in Brazil. The other institutions mentioned here are in Brazil. He was not, of course, a founder of UFPA in Sao Paulo, but he was a founder of the Department of Mathematical Physics there. In some ways, you can consider him to be the father of that department. And finally, the last section is another characteristic of Tiomno that was very typical. He was very interested in collaborating. He worked well with other people. He had a lot of collaborators, and many of them at the time or later quite famous people. And I'll just, if we have time, mention some of those. So let's go to part one. Just a little background. Tiomno was born on April 6, 1920. He would have been 100 years old half a year ago. And our book actually was planned to come out just on his 100th birthday, but due to Corona, it was delayed by a month or so. There was no reason to expect, given his background, that he would become a very talented theoretical physicist. His parents on both sides came from Russian Jewish families, and his grandfathers on both sides were grain merchants. They sold wheat and rye and other things of that sort. They both lived in what was then the Russian Empire, what is now the south of Ukraine. His father came from a small town out in the countryside, which is still there. It was in the province of Bessarabia. And his mother came from a much larger city on the Dnieper River. And the two of them both immigrated to Berlin in the year 1911. They didn't know each other. His father was just 21 and his mother was only a teenager, 14 at the time. They met several years later. But both of his parents, although they themselves had no formal education, valued education, and they made a great effort so that all of their 5 children were able to attend college, which was in those days, in the 1930s and 40s, not necessarily the case for everybody. An interesting side point is that the the same year Tiomno was born, Jayme Tiomno was born on the Brazilian national holiday, the first real university in Brazil was founded by putting together several faculties and institutions which had been professional schools up to that time. And it was originally called Universidade do Rio de Janeiro. It changed its name a few years later and became the Universidade do Brasil, and it's now the UFPA, as everyone knows. There was, however, a second university founded about the time that Tiomno was preparing to go to university in Rio. It was called Universidade do Distrito Federal, UDF, and it was founded mostly by Anísio Teixeira, who was a well-known educator at that time and was director of education in the federal district. And it was a much more ambitious project than the UB. It was a project which really aimed at being a research university, a modern university. Unfortunately, just at the time when Tiomno was about to start studying physics at that university, in addition to medicine at the UB, it was closed by the Vargas regime, who felt that it was a threat to them somehow. I'm not sure quite how, but this is a pattern that you can see repeated several times during Tiomno's life. So he wasn't able to study there, and the Faculty of Physics was transferred to the UB, and that's where he actually started studying physics. He had two majors in the beginning, medicine and physics, and he had to choose. And in 1941, he graduated in physics. Just the next year, Brazil entered the war, and Tiomno was taken into military service, which was, for him, a fairly serious problem. He spent actually 3 years in the army during the war, not doing anything very important. He first worked as a radio operator, and later he was going to officer school. But that really cost him 3 years of his physics career, because he wasn't able to do much during that time, except he was still able to do some teaching at the university, but he couldn't do any research or continue his studies. He was very impressed by the Italian professor who was at the physics department, the professor of theoretical physics, Luigi Sobrero, who had come from Rome. He had been an assistant of Relativity in Rome. But he had to leave, of course, at the beginning of the war, because Italians were then enemy aliens. And that was quite a blow to Tiomno and to other people. And in this picture, I'll show the picture a little larger. It's unfortunately not a very good resolution, but perhaps you can get an idea. This is the faculty teaching at the Universidade do Brasil in physics in 1942. And you can see here Jayme Tiomno. This is Elisa Foto-Pessoa, who was, Tiomno was at that time 21, and Elisa was just 20. This is Costa Ribeiro, who was their mentor, and this is Luigi Sobrero, who was the professor of theoretical physics. This is Jose Leche Lopez, who played an important role in Tiomno's life. They were good friends and colleagues for many years. Now we will quickly cover his career after the war. After the war, he got a fellowship to go to Sao Paulo, which he had realized by then was the place to go for theoretical physics in Brazil. He spent most of 1946 trying to catch up, because he had had only classical physics in his bachelor education in Rio. And he met Cesar Lattes at the beginning of his stay in Rio, who was 4 years younger and was just leaving to work in England. Everybody knows his name, of course. He became a very famous Brazilian physicist. And after Lattes had helped to discover the pi meson or pion in Bristol in England, he went the next year to Berkeley, where he and Eugene Gardner detected the first artificially produced pions. So he became quite a scientific hero at age 24, and he played an important role in founding the CBPF. Tiomno, in the meantime, after his fellowship expired, went back to Rio and started working with Leche Lopez. Here we see a picture of Lattice and Leche Lopez taken around a few years later, around 1950. But he was asked by Mario Schoenberg to go back to Sao Paulo in the middle of 1947. He became an assistant there, and he worked with Schoenberg on a problem in general relativity, which was quite unusual at that time. Not very many people, except for Einstein and some of his collaborators, were still working on general relativity at that time. The project was completed. They could have published it, but for a variety of reasons, it was actually never published. You could say that Tiomno's return to UFPA in this mid-1947 was the real beginning of his research career, but it was also the beginning of a lifelong relationship with Elisa Foto-Pessoa. She had been his fellow student, and she was, however, already married. She married Osvaldo Foto-Pessoa, and they had 2 children, Sonia, who is in the audience, and Roberto. But she and Osvaldo had separated, and when Tiomno returned to Rio in early 1947, they began a relationship which, in the end, lasted the rest of Tiomno's life, for another more than 60 years. However, they still had some obstacles to overcome before they could really get together. And as I mentioned, these 4 people, Jayme Tiomno, Elisa Foto-Pessoa, José Leche Lopez, and Cesar Lattice, were the people who really had the ideals and the drive to start the CBPF, although they needed help from some other people before it could actually be founded. After Tiomno returned to UFPA, he applied for a fellowship from the US State Department, and he was granted a fellowship to go to Princeton. But at the very last minute, he had to leave. He had no time to prepare because it turned out he had to leave in early February of 1948. So he had to abandon all of his plans for Brazil and rush off to Princeton, where he joined the group of John Archibald Wheeler, who was already at that time quite well known. Wheeler worked in nuclear and particle physics at that time. In fact, that was the period that Wheeler called in his own life, everything is particles. A few years later, after Tiomno had left Princeton, Wheeler made a very sudden and drastic change, leaving particle physics and starting work on gravitational physics, general relativity, and field theory, which he called everything is fields. And he worked in that area for another 20 years. However, an interesting thing was, which is not quite understandable, is that when Tiomno arrived in Princeton, he was given a project by Wheeler to work on general relativity, which was not Wheeler's field at all. And in fact, Tiomno complained that Wheeler didn't seem to know much about the field. He hadn't been working in it. They even asked help from Einstein, but didn't get much help. But as it happened a few months later, 2 things happened. One was that Wheeler had given the same suggestion to Infeld, who was one of Einstein's former assistants and who was an expert on general relativity. And he, in fact, did the project and published it about a year later, so that even if Tiomno had continued working on it, he might have had a lot of competition. And the second thing was that Tiomno discovered that Wheeler was also interested in the pion-muon decay chain. The pion had been recently discovered, recently detected by the British group, including Lattice. The muon had been known for more than 10 years, but no one really knew what sort of a particle it was. It didn't really fit into the scheme of anything. And Tiomno had already thought a lot about the weak and the strong interactions, or the possibility that there were 2 interactions, and what he called a universal Fermi interaction, which was his name for the weak interaction at that time. He mentioned that after Wheeler gave a seminar about meson physics, and Wheeler was very interested. So that was the end of their relativity project. And after that, they worked only on meson physics. And it was a very, very powerful collaboration for Wheeler also. He was enthusiastic about it even 50 years later. They published 5 papers within a few months. And that became Tiomno's master's thesis. However, Wheeler had to leave sooner than he had originally planned to go on sabbatical. in June of 1949. So Tiomno, who now had his master's degree, collaborated with a few younger people in Princeton, with Xian Yang, who later was a Nobel Prize winner, and with David Bohm, who later came to Brazil and was professor there in Sao Paulo for several years. And then he began his PhD thesis work with Eugene Wigner as his mentor. He finished the thesis under some time pressure in September of 1950 and went back to Sao Paulo. And we'll hear a little more about his thesis work below. Well, two other names that one should mention are Richard Feynman and Cécile Moret. Feynman was a former Wheeler student, and he often visited Princeton. Tiomno got to know him and suggested to him that he might like to visit Brazil. And he also suggested to Cécile Moret, who was a fellow at the Institute for Advanced Studies at the time, she was also quite young, about the same age as Tiomno, that she might like to visit Brazil. And both of them did. Feynman quite famously visited the CBPF in the summer of 1949, and Cécile Moret spent most of a year there and was one of the first lecturers. When Tiomno went back to Sao Paulo, he had essentially three major goals, three passions, one could say. One was his desire to contribute to fundamental physics, which he'd already started doing with his thesis. His second was his hope of establishing physics education and research in Brazil, and the CBPF had already been founded by that time. So that hope was also being realized. And the third was his love for Elisa, which neither he nor Elisa had really admitted to each other at that point. And that's an interesting story in itself, which we tell in the book. I won't say any more about it at this point. Now, in each of these chapters, I've suggested some reading that people who want to know more about the subjects might be interested in looking at. So here's the book by Alfredo's mother and Jayme Tiomno's youngest sister, which is a history of the family, of the Tiomno and the Aizen families, that is, the family of Jayme Tiomno's father and his mother. And these are two articles which are about this particular part of Jayme Tiomno's life. So let's move on. I have some pictures here, which I will show in larger size, if that works. Yeah. So this is Tiomno and Wheeler in Tiomno's first year at Princeton. He was, this was 1948, so he was 28 years old. Wheeler was 9 years older. And here we see a meeting, his first important scientific meeting, a meeting of the American Association for the Advancement of Science in Washington in September 1948. This is Tiomno, Lattice, who was visiting from California, Wheeler. This is Willis Lamb, who got a Nobel Prize a few years later for finding the Lamb shift. And this is Isidore Rabi, who had already gotten a Nobel Prize for his atomic beam work. And down here we have some other pictures from that point in time. This is a meeting of several friends, mostly Brazilian, in March of 1949 at Princeton. Up at the center here is Hideki Yukawa, who had predicted the existence of the pi meson. And here's Cesar Lattice, who had helped to discover it. This is Walter Schutzer from UFPA. Gervasio Carvalho, who had been a student at the UB at the same time as the others, and was a friend of theirs. He had also come from the northeast of Brazil to go to Rio, just like Leite Lopez. The two of them had come together, and this is Jayme Tiomno. All good friends at that time. And this picture shows Tiomno in his graduation gown and cap when he got his master's degree in June of 1949. So let's move on to the second section. As I said, this section is a step back from Tiomno's life, and it's a very quick survey of the three major themes, or what I like to call threads, of fundamental physics in the 20th century. Particle physics, or everything is particles, as Wheeler said. Gravitational physics, or everything is fields. and Fundamentals and Interpretation of Quantum Mechanics, or Everything is Information, as Wheeler put it. In fact, Wheeler had a motto for this particular area. His motto was "it from bit," meaning that everything we know about in the universe, comes from bits, quantum bits, information, the smallest particles of information. It sounds like the philosophy of idealism when you hear it in that form, and it's interesting that such a hard-headed practical person as Wheeler was quite taken with this idea. And of course, that field also includes the possibility of quantum gravity, which is still a goal, but a goal that hasn't been reached by theoretical physics. Now, I don't really have time to go through each of these fields in detail, but I just want to mention how they started. Particle physics can be dated quite precisely to the announcement of the discovery of the first elementary particle, the electron. The announcement was made by J.J. Thomson in England, but also Philipp Lenard in Germany and others. There was some controversy about who had actually made the discovery, and the discovery was completely experimental. This field was in the beginning not at all theoretical. It was quite experimental. The name electron was suggested some years later by various people, including Fitzgerald, Larmor, and Lorentz. It was also the observation of the quantum of electric charge, the first quantum that was actually discovered, and was precisely measured by Millikan 10 years later, 15 years later. The second elementary particle to be found was the photon, the quantum of light, and the messenger particle for the electromagnetic force. Its existence was suggested theoretically by the work of Max Planck, although Planck himself didn't believe in it. But he did find in his work that he had to include a quantization of energy, which was equivalent to the idea that light comes in terms of particles and not continuously. And the real experimental proof, besides the photoelectric effect, which was treated by Einstein in 1905, was Compton's discovery of inelastic electron-photon scattering, the Compton effect, in 1923. The name photon is interestingly enough, quite a bit older. It was coined by the physical chemist J.N. Lewis in Berkeley in 1926. And the third elementary particle, as it was thought at the time, was the proton, the nucleus of the lightest atom, hydrogen, which was identified by Ernest Rutherford, who discovered the nuclear model of the atom in 1911. But he did some scattering experiments which definitely proved the existence of the proton in 1919, and he was the one who found its name. Now, in the remaining 20 years before the beginning of the Second World War, several more particles were discovered. Another heavy particle like the proton, the neutron, it was found to be necessary for the structure of the atomic nuclei that had been measured, because it wasn't possible to make nuclei using just protons and electrons as Rutherford had originally thought. This was an experimental discovery that was made by James Chadwick in England and by the Joliot-Curies in France. And we have here a picture of the people who were working in this field at the time. Wolfgang Pauli called them the radioactives. This is Chadwick, who discovered the neutron. Here we have Geiger, who was part of the team that discovered the nuclear atom. This is his wife, Lily Geiger. And this is George de Hevesy, he's known for atmospheric physics, the Heaviside layer. Lisa Meitner, Otto Hahn, who worked together over many years and eventually discovered nuclear physics. This is Rutherford himself, the grand old man of radioactivity. This is Stefan Meyer, who was in Vienna and was Lisa Meitner's teacher there. And this is a Polish physicist whose name is probably not familiar, but who was also working in the field at that time. The radioactives had recently received a message from Pauli announcing a new particle, which was later called a neutrino, a neutral particle and a very light particle. In fact, they thought it was massless to begin with. So by now we have two heavy particles, the neutron and the proton. We have two light particles, the neutrino and the electron, and we have one massless particle, the photon. And in the remaining few years before the beginning of the war, Dirac's theory had suggested that there was an antiparticle to the electron, the positron, and it was in fact observed experimentally in 1932 by various groups. In 1935, Yukawa predicted the pi meson, proposing it to be the messenger particle for the nuclear binding force, in analogy to the electromagnetic force with its photon as a messenger particle. However, no one was able to observe it at that time. And the following year, a particle that no one expected was discovered by the team of Anderson and Neddermeyer in cosmic ray pictures. They called it the mesotron, and it later became known as the muon. And at that time, Rabi made the remark, who ordered that? Because no one had any idea what sort of a particle it was and how it fit into the scheme of things. Now, that was still the case in 1947, because basic research was essentially came to a halt during the Second World War. Nothing else was discovered. The neutrino and the pion had still not been observed experimentally in 1947. And so that was the point at which Jayme Tiomno got interested in particle physics. And that occupied him for the next 15 years. Here's, again, some suggested reading on particle physics. And you'll notice with each of these three themes, there's a book by Abraham Paes. The book I recommend here is his book Inward Bound, which is mostly about particle physics. Gravitational physics dates also from the early 20th century, and it was entirely theoretical in the beginning, in contrast to particle physics. And of course, Einstein was the initiator. In 1915, he published his theory of general relativity. He had some help from his friend Marcel Grossmann and Michele Besso. And that, of course, became the fundamental theory of gravity and the fundamental theory to this day, although there's some competition now. And in the first years immediately after his publication, several different solutions to his equations were found. His own solution for a closed static universe, Schwarzschild's solution, which was the very first solution of the Einstein equations for a spherical object containing mass, and Schwarzschild was able to show that it had instabilities. It had singular points. One of them is what is now known to be the radius of the event horizon of a black hole. It's called the Schwarzschild radius. And the other occurs at the radius 0. That is, if you go toward the center of what's now called a black hole, there is an instability or a mathematical point at which general relativity ceases to work. And of course, a famous solution was the Friedmann and Lemaitre solution, which implies that the universe is expanding. Einstein didn't like that idea, but it later became clear that it was the correct solution. In the years following 1930, general relativity essentially became a field which had gone to sleep. No one was working in it, except Einstein himself, but even he wasn't doing very much work. He published with a variety of different authors. I already mentioned Infeld, and with some others who had worked on very specific aspects of general relativity, but nothing really exciting. One paper was exciting, or two papers which were written by Oppenheimer and two of his students about the possibility that there actually could be such a thing as a Schwarzschild gravitational collapse, and leading in one case, if the mass of the object was not too high, to a neutron star, and in another case, if the mass was even higher, to what we now call a black hole, to a gravitational singularity. This was in 1939, and it didn't receive much attention at that time. However, after Wheeler changed his direction in the early 1950s and started looking into applications of general relativity to relativistic astrophysics and cosmology, a number of schools were founded. One independently of Wheeler in the US by Bryce DeWitt and his wife Cecile Moret DeWitt, and a school in England, which had a number of members, Roger Penrose, who just received the Nobel Prize yesterday, Stephen Hawking, quite a famous physicist, and an older generation, Siama and Isham. And also in the USSR a few years later, and in particular by Zeldovich, who was quite an active worker in the field in the 1960s and 70s. So there was what was called a golden age of relativistic astrophysics from 1960 to 1970. And it's now become an extremely active field because of observational and experimental successes. And you all know about that, the discovery of quasars, pulsars, the cosmic microwave background, the observation of gravitational waves, both indirectly and directly, the indirect and direct observation of black holes, another Nobel Prize just given, and won 3 years ago, and the questions of dark energy, and so on. And there are a number of conference series about relativistic astrophysics. Tiomno had actually started working in this field on his own with Schoenberg in 1947, even before Wheeler. And he continued throughout his career going back to this field several times. Again, a couple of pictures. Here we have Wheeler in the early 1950s, about when he started working in gravitation. This is one of his early gravitational students, Charles Misner, taken when he was quite a bit older. And this is another of his somewhat later students, a very famous person, Kip Thorne, who also received the Nobel Prize in 2017 for his part in the direct measurement of gravitational waves. And down here we have the DeWitts, Bryce DeWitt and Cécile Moret DeWitt, and of course, Stephen Hawking and Roger Penrose. And this picture shows Yakov Zeldovich. Oh, well, we've lost it, so we'll just go on. This is again suggested reading, again with a book by Abraham Paes. In this case, it's the biography of Einstein, which also gives a very good discussion of gravitational theory and the beginnings of general relativity. But of course, one can't fail to mention the Bible of gravitational theory, the book written by Wheeler together with Misner and Thorne, published first in 1973, republished 3 years ago after the Nobel Prize. It's simply called Gravitation, and it's very much worth looking at, even if you're not an expert on gravitation. It's very well written, intended for advanced students, but not so extremely difficult. Now, we'll just quickly go through quantum theory. We all know that it was Max Planck's theory of black body radiation in 1900, which led to the quantum theory. And Einstein, who proposed that the photon, in fact, was something real and not just a mathematical device in Max Planck's theory, for which he received the Nobel Prize in 1922. Einstein himself worked on what was then called the old quantum theory up to the middle of the 1920s. He worked on quantum statistics, electron spin, Planck radiation, and so on. But he remained later, for his last 30 years, unconvinced that the modern formulation of quantum theory was correct. And Niels Bohr worked also on the old quantum theory and was successful in describing the hydrogen atom with some improvements by Sommerfeld. But in the middle of the 1920s, a younger group came along, Heisenberg, Born, Jordan, Niels Bohr, who is, of course, not so much younger, Erwin Schrödinger, Dirac, and others. And that led by the end of the 1920s to what has become known as the Copenhagen interpretation of quantum theory. And it became a doctrine. It became a dogma, one could say. And the next 20 years or 25 years in quantum theory have been called the shut up and calculate period, because no one was interested in looking at the fundamentals of quantum theory or how it really works or what it really means or how it should be interpreted. Everyone was just interested in applying it and using it. And they were quite successful at that, calculating all sorts of things in atomic physics, molecular physics, nuclear physics, particle physics. And there was some progress made, for example, in quantum field theory, quantum electrodynamics, the first quantum field theory. But in the main, this period up to 1955 was just a time of consolidation and application of the conventional theory. One person who did was a skeptic of the conventional theory was Einstein, and he published his famous paper together with Podolsky and Rosen. By this time, he was in Princeton at the Institute for Advanced Study in 1935, suggesting that the conventional theory was not complete, that the Copenhagen interpretation couldn't be correct because it was, in his view, not a locally causal theory, and that there must be hidden variables in the theory which would make it locally causal. And they also pointed out that there is something which Einstein called spooky action at a distance, namely if two particles are in the same quantum state, then they can separate in space and still be connected with each other. Schrödinger coined the word entanglement for that. And interestingly enough, he coined the word in English before he did it in German. It's called Verschränkung in German, but he published his first paper about it as a reply to the Einstein, Podolsky, and Rosen paper in English. So he's really the one who originated the term entanglement. And in the modern world of quantum mechanics, as you know, it's become a very important topic. And I'll just skip over some of this. We all know that Bohm, while he was working in Sao Paulo, did in fact develop a causal theory of quantum mechanics. And Tiomno worked with him for some time on that. They published a paper together about the Pauli theory in Bohm's version, in his causal theory. And a few years later, this idea was picked up by John Stuart Bell, an Irish theoretician who was working at CERN in Geneva. And he developed his inequalities that must be obeyed by a hidden variable theory. And in the following decades, a number of experimentalists started testing. And what they found out was indeed that there are no hidden variables, and that quantum mechanics is not a locally causal theory, which would have caused Einstein a great deal of distress if he hadn't already died sometime before. And we know, of course, in these days, these topics have become extremely important for quantum computing, quantum information, and it's become a whole industry in itself. Jayme Tiomno dealt with many aspects of fundamental quantum mechanics. However, most of them were in the realm of mathematical physics rather than in the speculative aspects of quantum interpretations or in the practical aspects of things like quantum information. Again, some suggested reading. This book by Louisa Gilder, The Age of Entanglement, is very amusing. She's not a physicist and not even a historian of physics, but it's a very well-written book, and it describes the whole development of this subject of entanglement in quantum theory. It was published in 2008. In this book, she has recreated literally hundreds of conversations which are known to have taken place between various people, starting with Planck and going all the way up to the 21st century. But no one, of course, knows what was actually said in those conversations. One knows that, for example, Bohm and Feynman met in Belo Horizonte in 1951 at a meeting of the Brazilian Society for the Progress in Science, but no one knows what they said to each other. But Louisa Gilder invented a conversation, which is very amusing to read. I can highly recommend this book. And of course, again, there's a book by Abraham Paes, Niels Bohr's Times, his biography of Niels Bohr, in which he discusses the origins of the quantum theory in great detail. And here's a little different book. It's called The Philosophy of Quantum Physics, which goes into the philosophical aspects of interpretation of quantum physics. I translated it from German, so I'm familiar with it. Now we come to the heart of the talk, and I see it's already 20 after 4 almost, so I have essentially 10 minutes to finish. So I'll just go through this rather quickly. Tiomno returned to Sao Paulo in October of 1950, and that was really the beginning of his professional career. By then, the CBPF had been founded, and it was already operating, and his future wife, Elisa Foto Pessoa, had in fact published the first paper from the CBPF, which turned out to be quite an important paper, but it was unfortunately forgotten by many people, including Tiomno himself in later days. When he returned to the physics department at UFPA, it was in bad condition because its two important leaders, Lev Wadagin, a Russian-Italian who had actually founded the physics department there in Sao Paulo, and Mario Schoenberg had both left for various reasons. And things were rather disordered. And so Tiomno felt obliged to remain in Sao Paulo and not go immediately to Rio, where he could have joined the CBPF and could have rejoined Elisa. Instead, he stayed for a year and a half in Sao Paulo and did what he could to build up the department there. One of the things he did was to arrange for David Bohm to take over the vacant professorship, which had been vacated by Vatagin. Bohm was really not up to the task, but he had to leave the US because he was had been a member of the Communist Party. And in those days, in the McCarthy era, it was a very bad place to be if you were a member of the Communist Party. So he went to Brazil, and he fortunately came there at a time when the Communist Party was not illegal in Brazil. Actually, Mario Schoenberg had been arrested several times before and after this period for being a communist, but when Bohm was in Brazil, it was not a crime to be a communist. And during that time, he really started his causal theory of quantum mechanics, which was later called the de Broglie-Bohm theory. Some people call it Bohmian mechanics, but Bohm never liked that name himself. One exciting thing happened to Tiomno in January of 1951, which was that he informally married Elisa Foto-Pessoa, and they were together for 60 years. And in fact, they carried out their informal marriage. It couldn't be formal because divorce was still not allowed in Brazil at that time, so she was still formally married to Oswaldo Foto-Pessoa, although they'd been separated for some years. But they informally declared themselves married, and Tiomno died exactly 60 years to the day after their informal marriage. He died on their 60th anniversary. Here's the famous picture taken at the time of their informal marriage, which I will show you larger. This picture, I think, is a very nice one. It's on the cover of the book. It shows the two of them. Tiomno was 30. Elisa was not quite 30. She would be 30 a week later. And you can see they're both very happy. And in fact, they were a happy couple for 60 years, which is something that not many people have a chance to do. Now, what was it that Tiomno had done in his thesis that was so important? One thing was that he had separated the idea of the weak interaction and the strong interaction. The weak interaction, which is responsible for beta decay, and in fact, his thesis was about double beta decay. That was his main topic, an idea which had been introduced 15 years earlier by Maria Goeppert-Mayer, one of the 4 women who have gotten a physics Nobel Prize. And Tiomno realized that this strong interaction, which at that time was called a nuclear binding force, must be a different interaction from the weak interaction. And he also realized that the weak interaction must apply to a number of different processes. So it was the universal Fermi interaction. But the most important thing he did in his thesis was to find an operator, which he called the mass reversal operator. In modern terms, it's known as the chorality operator, which shows the handedness of a Dirac particle, whether it's a right-handed or left-handed particle. That is, whether its spin is parallel or anti-parallel to its momentum. And this was a very important operator, which later played a significant role in formulating the correct theory of the weak interaction, which came a few years later. Unfortunately, Tiomno didn't get credit for all of this because his thesis was not published, nor did he get around to publishing its important results in the next few years. Of course, Li and Yang proposed parity violation a few years later. Tiomno had already worked with Yang while he was still at Princeton, and they had published a paper together on the weak interaction. And what emerged from all of this in 1958 was what was called the universal V minus A theory, which was usually attributed to Feynman and Gell-Mann. Feynman had in fact worked on it in Rio in 1957 when he was visiting at the CBPF. They published the paper in the fall of 57, submitted it. It appeared in early 1958. In fact, it was actually Sudarshan and Marshak who had originated the theory, and Jayme Tiomno narrowly missed it. That's a story which is told in the book, and I don't have time to go into now. One can say that the 1950s were the golden age of the CBPF. It had problems. There were political controversies. There were financial controversies. But nevertheless, it became an important center for physics. It attracted people from all over the world, and people were able to work there very successfully. It had attracted students. Jayme Tiomno and Elise Foto-Pessoa brought a lot of students from the university to the CBPF, where they were able to do their graduate work, sent some of them abroad to do their doctoral work. Some of them stayed there. It became an important center. At the end of that decade, Jayme and Elise spent a year in London, a little over a year, and this is a picture of them at that time in Paris. You can see the River Seine in the background. This is on the bridge, which is right in front of the Eiffel Tower, the Pont d'Iéna. And if you, the two of them were there for a conference, and in fact, it was a conference on relativistic theories of gravitation. So you can see that at this time, Tiomno was still interested in gravitational theories, even though he hadn't been working very actively in that field. After that conference, he did submit a very important result in another field, namely the prediction of the K, what's now called the K star meson. He called it the K prime meson. And here's a picture of Tiomno with two of his younger assistants, Luciano Videra and Nissim Zaghari. And the three of them published a Fizerev letter in which this K prime meson was predicted. It was found very soon after that by Luis Alvarez in the Berkeley group. But the 60s were a difficult time for Tiomno. Things were going downhill at the CBPF. The funding was difficult. The administration was becoming more and more authoritarian. There were problems at the faculty also. It was also becoming more and more authoritarian. In 1965, Tiomno and Elise went to Brasilia to join the very optimistic and idealistic project of the Universidade Nacional de Brasilia, which was a very idealistic project for a real research university in Brazil. Unfortunately, it ran into trouble with the military dictatorship, which by that time had come into power, and it was essentially closed down in the fall of 1965. So after all of their work setting up the physics department, giving courses, the three of them, Tiomno, Elise, and Roberto Salmeron, gave all of the courses in that year. And they took a lot of students with them. They had to give up on that, and they went back to Sao Paulo, where Tiomno applied for a professorship, actually a professorship that had been occupied temporarily by Cesar Lattes for the last 8 years. But in the meantime, while he was waiting for the competition for the professorship to conclude, he went to Trieste, where the newly founded International Center for Theoretical Physics had just come into operation, where he was an associate. He was himself one of the contributing founders. And there he met two Argentine-Italian physicists, Carlos Guido Bollini and Juan Jose Giambiagi, and they started a collaboration. He had already worked with Giambiagi at the CBPF. They started a collaboration which continued over 15 years and was actually very fruitful. And here we see a picture of the three of them. Giambiagi, Tiomno, and Bollini in 1966 in Trieste when they were working together there. After returning, Tiomno took the chair in advanced physics. Cesar Lattes moved in disgust to the new university in Campinas, Unicampi, and spent the rest of his career there. Tiomno took the chair in advanced physics, and he spent a year setting up a group in mathematical physics, which in fact became the basis of the Department of Mathematical Physics there. So you could say he's the father of the Department of Mathematical Physics. But he only had a year because in May of 1969, he was declared subversive by the military regime and forcibly retired, along with a number of other people, including Elisa, Leche Lopez, Mario Schoenberg. Around 40 physicists were forced to retire at that time. So in fact, it was an ironic fact that the founders of the CBPF were mostly not able to work there at that time, because not only were they forced to retire from public institutions like the UFPA in Rio, they also were forced to retire from the CBPF. It was a private foundation at that time, but its president was very conservative, and he declared them to be retired from there as well. This was a very difficult period for many people, and in particular for Tiomno, but he was invited by Wheeler and by Freeman Dyson to go back to Princeton, which he finally did in early 1971. He and Elisa went there and spent a year and a half. And there he began working very seriously in the field of gravitation, relativistic astrophysics, and cosmology. In fact, in that year and a half, he published 13 papers, some of them in collaboration with other people, some of them working alone. And that was a very fruitful period, and it really determined what he did for the next years. I have some pictures here, and we're getting down to the end of the time, so I'll show these pictures and then go quickly to the conclusions. Here we see Jayme Tiomno, Mario Novello, who had been a student of Jayme and Elisa's. In fact, he was one of the people who went along to Brasilia. He had founded a group in cosmology and relativity when at the CBPF during the period when Jayme and Elisa were not permitted to work there. And after Jayme was able to go back in 1980, they together founded a new department of particles and relativity. This picture shows Elisa with Wheeler after Wheeler was finally retired. This was in 1993 when Jayme and Elisa were visiting the Wheelers back at Princeton, where they were retired by then. Here we see Jayme and Ivana Suarez, who was his last collaborator, a younger physicist who had been a student of Novello's and who collaborated with Jayme on his last physics projects. And here we see Leche Lopez and Jayme Tiomno in 2002. They were receiving the institutional award of the Marcel Grossmann meetings, a series of meetings which were founded by Remo Ruffini and Abdus Salam, both collaborators of Jayme Tiomno's at various times. Tiomno was never very enthusiastic about those meetings, but in this case, the meeting was held in Rio. It was the 10th meeting in 2003, and the CBPF was given the institutional award. And there are two of its founders who were just receiving the award. Leche Lopez is looking surprised because the flash disturbed him from the photographer. So I will skip over. Here's the list of suggested reading, a number of different books for this section. I will skip over the institutions which Tiomno helped found, just to mention the CBPF in Rio, the ICTP in Trieste, which he worked together with Abdus Salam to found, the physics department at the University in Brasilia, which unfortunately was unsuccessful in the beginning, but of course it later became a serious institution. The mathematical physics department at UFPA, the Brazilian Society of Physics, of which he was also one of the founders. And the fifth section, collaborative physics, he had really many collaboration partners. His very first serious collaborator was Leche Lopez. Here we see a picture of him in the early 50s. This is taken from a larger picture. I'll show it in a larger size here. He was sitting next to Wolfgang Pauli, who was one of his thesis advisors. He was actually, Leche Lopez was the first Brazilian physicist to get a doctoral degree outside Brazil. And one of his mentors was Wolfgang Pauli. And Pauli had just made a joke, and so Leche Lopez is laughing earnestly at the joke. And here we see Wheeler and Yukawa talking to Einstein in the early 1950s. Here we see Wigner, C.N. Yang and David Bohm, all about the time when Tiomno was collaborating with them. He did his thesis under Wheeler. He wrote a paper with Yang and another paper with Bohm a few years later. And here we see Abdus Salam, who was also an important collaborator throughout the later 1950s and 1960s, and not only in doing physics, but also in establishing institutions, in particular the ICTP. And here again, Giambiaggi and Bolini. This is Remo Ruffini, with whom Tiomno collaborated while he was at Princeton in the 1970s. Leonard Parker, who was also a collaborator there. And this is one of his later collaborators, Enrico Pedazzi from the University of Torino in Italy, with whom Tiomno collaborated in the 1980s. So again, suggested reading. Some very interesting works here. And now I'll come to the conclusions, because we're over the time already. We can see that there were three major strands of fundamental physics in the 20th century. They wound together sometimes, like a braid being plaited together, but they also separated at other times. They had periods of rapid progress and longer periods when nothing was happening at all. Those three strands still exist, and none of them has been closed off yet. None of them has really reached a conclusion. Particle physics reached its first climax with the standard model of particle physics, which we're all familiar with. But everyone agrees that that's not the last word in particle physics, but no one has found anything, the new physics, which goes beyond it. Gravitational physics also produced a standard model of cosmology, but there are many, many questions open in that also. And fundamental quantum mechanics has given a rise to many important new fields like quantum optics, quantum information, quantum computing. But the holy grail, quantum gravity, has still not been reached. And here I'd like to show, just at the end, two pictures, which one historical and one much more recent. This is a picture which you've probably all seen. It hangs in the entrance hall in a large enlargement of the CBPF. It was a lunch given in early 1952 at the CBPF. We see here the founders. There's Cesar Lattis, there's Leche Lopez, there's Jayme Tiomno. Here, there's Elisa Foto-Pessoa, and just in front of her is Richard Feynman, who was visiting at the time. And this is Elisa's first research student, who also was a co-author on the first paper there, Neusa Marjam, who later was, with her married name, Neusa Amato, who worked for many years at the CBPF and was very successful in research. And this picture is a more personal picture. Here we see Jayme Tiomno's two adopted children, Roberto Foto-Pessoa and Sonia Foto-Pessoa. This is Roberto's wife, Sueli Braga. This is Alfredo's mother, Sylvia Tiomno Thomas Kim, who at that time was celebrating her 70th birthday. And there am I, looking much younger than I do now. So I thank you for your attention, and I'm happy to take questions if we still have time for some. And I'll end the presentation.
First of all, thank you very much, Bill, for this wonderful presentation. First of all, I would like to ask everybody to turn on their microphones for us to acknowledge this excellent talk with...
Thank you. Thank you.
Okay.
We covered a lot of history in a very short time, and I'm afraid it was very compressed, but all I can say is download the manuscript and get the book. You may find a way of getting it without paying for it. I'm sure there are a few floating around by now.
Okay. Well, I ask you to all turn off your microphones for a moment, and you can register in the chat either your question in the case you want me to read it, either You just write, I have a question. It can be in Portuguese, it can be in English. I can translate if it's in Portuguese. So while you register, we already have questions, but while you register your questions, let me just give a picture to Professor Bill Brewer of the audience for him to, so we have representations from all around Brazil, from different Brazilian regions, all around, I mean, starting from obviously Pará and the big state of Amazonas in the north region, to the extreme south in Rio Grande do Sul, like cities of Santa Maria and Santa Catarina, like Joinville, obviously passing by the central Brazil and Brasilia, and also obviously Rio de Janeiro, from Rio de Janeiro capital, Niterói, São Paulo, from São Paulo capital, and Campinas. I have also to register. Well, we have more than 70 participants in Google Meets and YouTube, and we have obviously the presence of the teachers and professors of our department here, physics department in Federal University of Pará, Professor Ângela Clautal, Caio Macedo, Jorge Cassineiras, Marcelo Lima, Newton Barbosa Neto, Van Sérgio Alves, plus a lot of students. I'm very happy that we have representatives of the CBPF and many federal institutes and universities in Brazil, right? And also from abroad, as I have mentioned before. So I would like to mention, I cannot mention all of them, but since this is a special occasion, as I mentioned, I would like to register the presence of some of teachers and professors from all around Brazil. Alfredo Tiomno Tomasquim, Anderson Janotti, Fernando Sassi, Gabriel Denicol, Helena Petrilli, Isaías de Oliveira, José Ademir Lima, Marcelino Cordeiro Neto, Marcelo Gomes, Marcelo Rebouças, Marcos Maia, Maurício Calvão, Miriná Lima, Nelson Studar, Nissim Zaguri, Oli Erickson, Ribamar Reis, Rosiclívia, Sati Skuma, Rona Pata, and Sônia, last but not least, the opposite, as Sônia Frota Pessoa. So as I said, there are moments in life that apart from being an academic activity, is also an activity that brings you a lot of sentimental vibrations, and I'm very happy with this special talk. So thank you very much, Professor Brewer, for your excellent talk, as I said. So we had comments in the chat congratulating you for the very nice talk, and I'll start with a comment and question by Marcelo Lima, here from Federal University of Pará. It's not rare to find in the community of Brazilian physicists those that believe that the threats suffered by CBPF in the first years after Getúlio Vargas, our president's suicide, are connected to the ambitious role that the Institute was supposed to play in the construction of the national sovereignty, in this idea of the Vargas era, as we used to call it in Brazil, what would include to be, for us to be in the front of this nuclear time, right?
Yeah, it had a name, I believe.
Yeah.
This ambitious project to be in the forefront of technology.
Yeah,
what was it called?
Well, I don't know if Marcelo wants to register that because he's more involved with that. I don't remember the precise name, but it was we call it Vargas era as a whole, right? But for the nuclear initiative, I don't remember it now. But so Marcelo asked you if you could make comments about that. So please, Bill.
Yeah, well, of course, there was a crisis in 1954 and 55 at the CBPF, and I mentioned it was both political and financial. It was a financial crisis because the person who was the essentially the treasurer of the CBPF and also for the CNPq was had taken some money which was intended to be used by the CBPF, and in fact He apparently lost it in gambling, I think at Orca, which was still operating in those days. And this wouldn't have been necessarily a problem, except that César Lattes, who was scientific secretary of the CBPF at that time, was worried that if it became public, he might be implicated as being part of this problem. And so he went to the press and told them about it himself. And that made it a very difficult situation for everybody. And the CBPF was divided 50-50. And the political aspect was that the admiral who was president of the CBPF at the time, vice president, and was also head of this CPNK, was removed from his office by more conservative people because they claimed that he was getting in the way of this project of developing nuclear power and was selling thorium-containing ores to various people to finance some of his projects. And so they used this scandal at the CBPF to get rid of him. Now, all of this is very complicated. It created a collapse of the organization for a short time. It was a catastrophe for César Lattes, who ended up leaving the country for a couple of years and having a major crisis. But in fact, the CBPF survived it and was able to find other funding. And so it finished out the 1950s still as a quite successful institution. It was only at the end of the 1950s that the funding problems again began to be. During the Juscelino Kubitschek era, it was quite successful and had support. So I think it wasn't just that that crisis in the mid-1950s that caused problems. It created a split. It created a split between Tiomno and Lattes, who had been good friends at an earlier time, and after that they, well, I wouldn't say that Tiomno ever hated Lattes, but Lattes seemed to have hated Tiomno. It was a sad situation.
Okay, Marcelo, thank you for your question, and Bill, thank you for your answer and comments. Well, let us move then to the next person to talk. Before that, I'll just like to mention that we have many people writing compliments. Maurício Calvão, Helena Petrilli, Sonia, congratulating you for the great talk. And so the next person to comment is José Ademir Salles de Lima. Ademir, please, being the last student of PhD student of Jayme Tiomno, I'm sure you have a lot of things to say. Please go ahead.
Okay, thank you, Crispino. First of all, I would like to congratulate William and Alfred by the publication of this book about Tiomno's life and science. Actually, this is a great contribution for the Brazilian memory. Why I say that? Because I think that Brazilians don't care a lot about our artistic, scientific, and historical memory. Perhaps, I think from my point of view, this happened because we have our culture has a lot of contribution from the Indians. Brazilians are more or less 30% Indians, 30% Black people from Africa, and the 30%, more or less 30% Portuguese. The Indian culture dominated in the beginning of the Brazilian culture. And the Indian culture is more oral, is more to talk. Perhaps this explained because our, for instance, in music, Brazil always gave a great contribution. Not in science until now, although the the contribution of the pioneers in Brazil that was very, very important, as you have seen in the lecture. But it's interesting, and the people work in science need to think about that. Our memory, we don't write in many areas of the knowledge. We don't write about our memories. This is a Brazilian phenomenon. I will give an example. This is a book. This is a book about Luiz Gonzaga. Luiz Gonzaga was a very important artist in the 40s, in the 50s, and the 60s. This book about the life of Luiz Gonzaga, the name is The Saga of Luiz Gonzaga. And this book was written by a French woman, living in Paris, about our Luiz Gonzaga. And then it's very important. This is interesting because people from outside, like William and like Dominic Dreyfus, take care and are right about the Brazilian culture. And then I think that the Brazilians need to have some conscience about that, and that it is very important to have memory about our activities, about our culture, about our history. And I am very happy to see this seminar of William and to have access to the book. Because for me, this is a very great contribution to our scientific memory. And I would like to say thank you, William. Thank you, Alfredo, by the courage and by the time spent by the time to write this book. This is an example that I think that scientific workers and the artists and the writers in general need to do. This is a very great example. I remember now something personal. I remember that Elisa, when I met her several times, and she stimulated me to write something about, because I had written something about how Tiomno became my advisor at PhD, and how this happened, how he was important to my scientific life. She stimulated me a lot to sometimes, when I meet her, to write something, because she read a test that I wrote about that. But unfortunately, I was not able until now to write something about Tiomno, but I am very happy to see that this great book has been written. I'd like just to call attention, I will finish here with two comments. The first comment is that Tiomno also worked and gave importance to two subjects. One of them is the foundations of special relativity theory. Mm-hmm. He has several papers about the foundations of the special theory, not only in general relativity theory, and he discussed with some collaborators, for instance, the synchronization process used by Einstein, and if you change the synchronization process, what kind of a more general theory you have beyond the Einstein special relativity theory. And this was an important contribution, I think. It spent a lot of time discussing with the referees about a paper on the foundations of the special relativity theory, done in collaboration with Valdir Rodrigues of Unicamp, and he told me sometime that after 10 letters between him, Valdi, and all the referees, and talking with Wille, he said Wille asked him about what he was doing, and he said, "No, I did a paper about foundations of special relativity theory, but we have had already almost 10 referees about that, and this is a great confusion on the foundations of the special relativity theory." And then he told me that and of course this process takes a lot of time. And then he said me that Wille talked with the editor of the journal, talked the following: if you don't have, if it is referee, all this referee has nothing very strong that show that the paper is wrong, I think that you should accept the paper, because I know Tiomno. Tiomno is a very serious work in science. Is a very serious scientist. And if none of these referee has something that show that he's wrong, he and his collaborator, I think that the paper should be accepted. He said me that. Another thing that I think that is the moment to say is a talk, a personal talk that I had with Tiomno about what I called it later on the tolerance principle. His tolerance principle. I asked him, Professor. I used to call him Professor Tiomno. And then I asked him, when you have a collaboration, you are doing a paper with someone, with a given collaborator, and he think that that part of the paper should be included. But we don't agree. Since you have worked with several people along your life, what you think that you should do about that at this moment? Your friend wants to put that part in the paper and you don't agree. And then he said to me, Ademir, you need to be a little tolerant. And you should think in this way. Okay, you want to include this in the paper. And then you should think, the paper is at risk, not to be accepted due to this inclusion. You need to think about that. If there is no risk, you should agree with your colleague, because perhaps this is very important to him. And he feel him included in the paper by that addition, because this is very important to him. And then if the paper is not at risk, you should agree with your friend. I call it that the tolerance principle in the scientific collaboration. Okay, this is my comments. These are my comments, and I'm very happy to have access to this book. And congratulations again for your very good seminar.
Thank you very much. Just to comment to your comment, Tiomno had during his life many complicated experiences like that. Like actually, we described that in the book of his work on special relativity and the fact that his paper was delayed by almost 5 years, and this incident with Wheeler. But he had a similar problem with Remo Ruffini while he was working at Princeton. And I'm not quite sure what happened. We haven't been able to find exactly what happened. But the fact was that he and Ruffini and two younger physicists wrote a paper together. They agreed to send it off. They sent it to the physical review. It was in already practically accepted. And Ruffini suddenly wrote a letter to the editor saying, don't publish it. And Wheeler had to intervene at that point also. And this was, I think, a sort of difficulty between Tiomno and Ruffini for many, many years after. I'm not quite sure what happened, but it was the reason that Tiomno was never very enthusiastic about the Marcel Gossmann meetings, which were organized by Ruffini. But he was a very tolerant person. And I think that's a very important aspect of his personality, that he was able to collaborate successfully with so many different people. Not only younger people, but also people of his own stature, and that's rare.
Okay, thank you, Ademir, for your comments. Thank you, Bill, for your reply. And I would just like, we have more comments from other people. Then I should register that Jose Clivia Santos wrote that, well, congratulations for your excellent seminar. And she would like to inform that there is the workshop, 60th workshop on cosmology and astrophysics at UniFesp, which will honor the 100th anniversary of Professor Jayme Tiomno. It will start on November 30th. Would you like to say something about that, Jose? Okay, I think it was just to register that. Alfredo Tomaschini.
Crispino.
Yes, please.
Rose asked me to say that not only this meeting about the 100 years of Tiomno, but at the end of the year, in December, we will have a new meeting in Natal through internet, of course, also to celebrate the 100 years of Tiomno.
São os dois eventos, né?
We have at least two events in this pandemic ages.
Okay, great. Thank you, Jose, very much. Thank you, Ademir. We have a question from Caio. Caio Macedo, please go ahead if you want to turn on your microphone. And
thank you, Crispino. Thank you, Professor William, and also Crispino for organizing this very nice seminar in the graduated program of the University of Pará. Actually, I have a very quick question. I knew Tiomno because I heard about him because of Professor Basalo, that usually spoke very well about him in his seminars, and I had the opportunity to learn a few of his works during my PhD, and I was quite impressed by the effort that they made in the 70s to compute the gravitational radiation from perturbative regimes in general relativity. And watching your seminar, I was amazed that a person so young was given such a huge responsibility in pushing science and physics in Brazil, also his colleagues. And I was thinking about our generation, because it's very difficult, at least for me, to see young people like they were at the time receiving such a thing, such a responsibility. And also, it seems that even though at that time it was very difficult, I imagine much more difficult than what we have now to pursue science, and even though they managed to do it very, very well, and now we have a much more, let me say, it's easier because you receive everything in your email, you can access everything from everywhere, and basically we don't see such prodigies, and at least, perhaps they are more diluted. But my question is basically seeing the history like that, and seeing what we have now, the times that we are facing with with those crazy ideas, non-scientific ideas proliferating around our world, what do you think have changed for our time, and what we can do to create more people like Tiomno, Cesalatis, and Prof. Pessoa, and so on? Thank you.
That's a very interesting question, and I wish I had an answer to it, because I agree with you that the times are very difficult, and whenever anyone says a serious scientific pronouncement on the internet or on television or wherever, immediately 50 people pop up from the woodwork with crazy ideas. I don't know how to make integrity important again. But if you look at the political situation in the US, in Brazil, you can see that this is not just a problem in science, it's a problem in society in general. And I don't know what to do about it, but I think it's the most important problem facing us right now, because we won't be able to solve the problem of climate change unless we solve the political problem of getting people to accept the science in the beginning and do what's necessary. And I think if I were younger, that would be the thing I would dedicate the rest of my life to. As it is, I'm old enough that I can excuse myself from that, perhaps.
Okay.
But thank you for the question. It's a very relevant question for these days.
Okay, Caio, thank you for a question. Thank you, Bill, for your answer. Well, I think everybody has some comments, right? And I have mine. I mean, I should not do them because I'm supposed to be here just to mediate the. But anyway, maybe I cannot control myself as usual. I'll just I have two things. At least I'll say just two things, right? One thing goes in the direction of what Caio. So in Caio PhD, so we have revisit essentially these calculations of radiation emission in the vicinity of black holes, but now from this machinery of quantum field theory in curved space-time, and also with this numerical resources that we have today. And we are still working in that. I mean, Caio is not now, but other students of mine are making this kind of calculations still in different space times, in different contexts. And we meet this Tiomno and collaborators works that have been very inspiring. And what Caio said is essentially what we all in the group feel, that is just this recognition to the role played by Tiomno. And this goes in the meets essentially Ademir comment about the absence of recognition. Well, in here also in our group, and here as a team of people is now trying to do this recognition with, important physicists in Brazil, and this touches upon, people like Jayme Tiomno, and also the people that are still around, and they gave very important contributions to Brazilian physics, but it seems like we just don't pay the obvious attention to this and notice that this is important for our future. But and it makes me ask, to myself and to others, obviously, and to you, obviously, because so why don't it's not that usual that some people just take a bit of their time, to dedicate to the history of the people that paved the way, right? So obviously I should not ask this to you and to Alfredo, because you're the ones that do it, right? But I try to think, in kind of answering the comment of Ademir also, and what you said, that in Brazil here we have so many things to do that we should not be doing, like bureaucracy of all kinds, and we're like the responsible for setting things up and fixing some crazy things that maybe if we were more had more time to do science, we will also have more time to write about the history of science. I don't know if you want to make your comments about that. And
Well, having worked in university administration for a couple of terms, I can say that problem is not just Brazilian. It's a problem everywhere. And once you get involved in the administration, it's like an octopus that has many arms that grabs you from every side. There's no way to get out of it, and there's no way to save your time. It's sad but true. And I think the only answer is to reduce the size of administrations compared to the size of the people who are actually doing the work. And that applies to universities, it applies to research institutes, it applies to hospitals, it applies to many, many things. Administrations have become a big sort of overblown head while the body is shrunk to almost nothing. And that's a serious mistake. And it's happening everywhere. Some places it's more institutionalized than others, but it happens everywhere.
Okay, so thank you once more. Yes, Marcelo, please go ahead. Professor Marcelo Gomes, por favor, please go ahead. Alfredo?
Yes, I
Alfredo,
would like to make some short comments. First of all, to thank Bill, who invited me to share with him this initiative. And I am very glad I had the opportunity to do that. And also Sonia, Elisa's daughter, and who helped us a lot with much material and information. And also Nissim Zaguri, who is here attending this conference, who gave also much information for the book. But what I would say, this point of the memory that Crispino and Ademir pointed out is, I think it's important to make, I make a history of science, and I understand, of course, history of science is important as a kind of memory to memorize people of the past and his activities, but not just that, not just mainly that, but I think the history of science is a form to understand, to learn with the past and to plan our future. I understand that in Brazil, maybe we don't care so much about our memory because we don't think so much about planning the future. If we plan much more about the future, maybe we could take more care about our past. So it's very important not to repeat the same mistakes and the same problems that it's impressive. For example, when we surveyed the documents during the period of the dictatorship in Brazil, and we can find many, many elements that we can find again at this moment we are facing. So it's really a kind to understand our past, to help us to address correctly our future.
Yeah, that's very true. And of course, it's a problem in Germany also because the past is very difficult here. And many people would rather not address the past, but I think it's very important to do so because, and it's something that Tiomno also said in his famous inaugural address at the Universität do Pará in 1986. He was invited to give the semester inaugural address. And that was one of the things he said, was that Brazil has no memory, and it's very important to look at what has happened in the past. And that was right after the end of the dictatorship. And keep it in mind for planning the future.
Okay, so thank you, Alfredo, for your comments. Very important. Thank you, Bill. or also mention the Pará University, in which Jayme Tiomno has been visiting. And I would like to, I know it's a little bit late for that, but I think you're still in the presentation mode, and maybe when people do their questions and comments, they do not show their faces. So if you could stop the presentation mode. So maybe, I think Sonia has a comment, and Sonia, would you like to turn on your microphone? And
Yes, I think I already did, huh?
Yeah.
My comment is the following, I think history of science is very important because the only way we are going to really get support for science is if the Brazilian people are proud of our science. So this happened in São Paulo in the past. People were so proud of the University of São Paulo. São Paulo had such a joy in being first that they founded FAPESP, and they had a percentage of the income of the state assigned to the university. This is no longer true. Nowadays, we see that people are sort of de-emphasizing the public universities, saying they are, mainly for drugs and that they do everything wrong and all this sort of thing. And that sticks on the mind of the population when they are thinking about money. So I think that we have to be responsible for making a bit more propaganda, because we certainly have very good science. It's been shown during the Corona crisis. All our fantastic institutes, we do have great science. But Brazilians are not proud. They don't even know about it. So this is one more reason to really care about our history, and for us professors to do the most propaganda in newspaper. Corona is being a beautiful thing for that, because all our institutes are in the TV and people are recognizing that we do have good science, And I remember when I was in my career, once I was inviting a postdoc because he was responsible for making a program from which I wanted to extract something to put on my program. So I invited this young postdoc through FAPESP. And even being FAPESP, the answer was, he is not mature enough to teach us something. And they never suspected that I was the one that was teaching. He was just someone that was, giving me the means in terms of programs to do the things that I had planned. I convinced FAPESP. FAPESP is a great institution. It's very easy to convince it because they know what science is about. But that's how Brazilians think of themselves. They just think that people from abroad know more, and all you can do is learn. So that's my comment. Thank you.
Can you hear me?
yes.
Good. I would like to suggest, following up on that comment, that it would be very nice if someone would translate this book into Portuguese. I could translate it from Portuguese to English, but not the reverse. And I think it would be very good. That was one of the reasons we wanted to write it, was so that especially the younger generation would know who went before, and the younger generation of Brazilians, but not only physicists. It would be, the story is a very interesting human story as well, aside from the physics aspects. And I think it would be very nice if someone could be found who would translate it into Portuguese.
Okay, so thank you very much, Sonia, for your excellent comment. Thank you, Bill. Well, having said that, Bill, I'm afraid that Alfredo is now with the responsibility of translating it to Portuguese.
Well, he
I'm
has to
sorry.
find a publisher who will pay for it, and then
Well, I mean, Alfredo, you have all imaginable support for that task, right?
So if we find an editor, I will be very grateful to do that. Yeah, I think we should do that.
I think so too.
You know, I know that it's a bit late. I mean, we're coming up to 2 hours of our meeting, you know, but I must tell you that we have, when we add up Google Meets and YouTube, we have more than 50 people around, and I think they are enjoying. So we have still one registration, apart from the compliments for the excellent webinar, excellent talk of Bill. Thank you very much once again. Ademir wants to talk again, but Ademir, I would like to ask you to be as fast as possible so that we don't extend very much. And this is the last comment. Please go ahead.
Okay, Willem, I would like to know if in your book you talk about the participation of Jayme Tiomno in the International Conference of Physics Teaching in 1963. This was a very important international conference, and there is a book, Why Teach Physics? And Tiomno is one of the authors, I think.
That's a major section in the book. We do talk about that.
In the discussions during the conference.
Yeah, we talk about that. We quote from the book. We quote Tiomno's article, and also Feynman's article. He gave the keynote address at that conference. I think that had quite a lot of influence at the time. You're right, and that was an example of Tiomno's engagement for education, which he did not only in Brazil, but actually worldwide. He was a member of the IUPAC Commission on Education for a time. He had to stop doing that because of his blacklisting by the dictatorship, but he was very active up to that time.
I also think that the conference has an important influence of Elisa to do the conference in Rio de Janeiro.
I think everything that Tiomno did had an important influence from Elisa. She was a very powerful figure, and the book is of course not only about Jayme Tiomno, it's about Elisa. And it's a kind of memorial, because when we started writing the book, she was still living. And actually, just when we were writing the chapter there's a chapter about Elisa, especially, and it was just when we were writing that she passed away.
I would like just to say something about the Sonia comment. I think that his comment was very important, mainly at this moment. I remember that 1 month ago, I have a discussion with some people living in my condominium about the importance of the São Paulo University. This is incredible to me, because the public university in Brazil are under pressure. People don't know that in the university happened almost a revolution in Brazil, because you don't have the structure of the research structure in Brazil was located in the Sudeste, here in São Paulo, here in the axis, Rio, São Paulo. But now we have a structure of research in Brazil, in the whole country. And peoples are attacking with absurd arguments that they don't know what means science, they don't know experience with science, and they don't know how to correlate development and science. What they think is just things related with the success. what the university is doing now. There is some kind of manchette appear in the journal that the university did that. They don't know. They don't know how, for instance, it was possible to Brazil for instance, to discover the pre-sal, the petroleum of the pre-sal. They don't know that the Petrobras, during a long time, contracted physicists, geologists, mathematicians, and engineer to have this technology of how to catch petroleum in profound waters.
Yes, and let me tell you that they just sold Petrobras for nothing. You know, well, I know that
it's not my comment on Sonia important question.
I'm sure that, I mean, we could speak here for hours, right? But I mean, in terms of organization, I think we should come to an end. If you were here, I would be glad to invite all of you to have lunch. You would not sit in my house as I am now, right? But I mean, we surely go to...
I wish I were in Belém. I would be very happy to be there.
Estação das Docas or Mangal das Garças. That will be a great pleasure, I mean, to keep on talking with you about these very interesting subjects. But actually, I have to... Yes.
You have to close, I know. I just wanted to make one final remark. The thing I found most impressive about Belém is the rain. When it really starts to rain, it's the most impressive thing I've ever seen.
Yeah,
it's
that's
like waterfall is coming down.
Other things are, I don't know, trials, but here we have the real rain. Exactly. So, well, thank you very much. I have no words, I mean, to thank you more than I already did for your excellent, wonderful talk. I mean, it has been said before. I mean, you and Alfredo, but if I understood right, the initiative came from abroad in the sense to write a book in recognition.
It came from the editor in Springer, the Springer publisher, who is an English lady who came from Cambridge and has been an editor here in Germany. She was the one who suggested to me, you know, you should write a book, stop translating books, write a book. And so I did, and the first person that came to mind that I should write about was Jayme Tiomno. So.
Yeah, that is great. And I hope you keep on writing because you do it wonderfully. Our compliments to you, to Alfredo. And well, to thank you again, a final thank you acknowledgement. I would like to ask everybody to turn on their microphones once again for us to clap our hands in retribution for this wonderful webinar. Thank you.
Thank you very much.